This is test ID 3C, component ID 80. It's the pre-catalyst oxygen sensor, B2S1. It's a change or delta in voltage during the O2 test. The component ID 80 indicates a minimum limit. This is the left or the front on a transverse mounted engine when dual O2 sensors are used for fuel control. The PCM times the change in O2 voltage during periods of rapid change in fuel control. Now, special note, JTEC O2 sensors have 5 volts present when they're cold. If you can only read this 5 volts if you used an enhanced OBD2 scanner, like the OTC Modus, or the OTC Genesis, the Snap-on Modus, or a V-Tronics. You may want to review the JTEC O2 sensor operation to make sure you understand what's going on. The sensor must be at operating temperature for this test to be accurate. The values aren't converted into measurement values by Chrysler, so use the data as a relative indication of performance. We'll use vehicle data to show typical results. Here we found a failure. The minimum limit is 17. The actual value measured was 3. We failed this monitor. Now we're going to use snap accelerate tests and other things to help us identify the problem. Now using the scope patterns on O2 sensors will help direct us to a problem area, even though we may not always be able to absolutely identify the exact component that caused the failures. It's the best way we know of testing oxygen sensors. Now, the red scale is on the right and the green scale is on the left. Notice the slope during the warm-up period. We're going to let it go live here in just a moment. This is fuel control. Starts off at 1.5 volts on the left, drops down to 1 volt on the right. Now, JTEC has special warm-up procedures. Make sure you go look at that section because you need to understand how this works. We have changed these readings by attaching a lab scope, but you need to be aware of that. Notice in the center here, we drop below 1 volt and we start seeing some activity. That's the indication of fuel control. Now, once we get into fuel control, we can change to 1 volt on these scales, and you can see we are, in fact, in fuel control. The warm-up is complete. This is where we should see fairly quickly after we start up. Now let's go back and look at this and talk about why we had to change scales. If we look just back at the plain scale, we're looking at a 100-second scale here. As you can see, once we start looking at it, it stays the same until we change scales. We can't tell much about it, but this is what fuel control is going to look like if you stay on the 5-volt scale. And you need to be on the 5-volt scale to start this process. So we're spending a little more time here than we normally would. But now let's go back and look at the whole thing so that you know what's going to happen. We're going to start off high. It's going to drop down in the middle. And this is all about the heater, remember? So if we're worried about warm-up, we need to start worrying about the heater. And to get to this point, the heater's going to have to operate properly. And as we said, once we're here, we're fully warmed up. Well, let's say it takes too long. Then we need to go examine the heater. We're going to look at the voltage and the current. And we're going to do a starting test. Did you see it? We turned the key on. Here, we stopped it so you could see it. At key on, we got battery voltage from the SD relay, and we had heater current. Now, we're going to examine that current more, but you're going to have B+. You need a good schematic like this in order to diagnose it. If you don't have a schematic like this, get one because you can't diagnose any other way. Remember, this works because of the 5-volt pull-up on a cold sensor. So let's talk about this current flow. We can make some measurements of this current flow. Here is our measurement at startup. We had 1.89 amps at startup. This means we have full power and a good ground, and the resistance of the heater element is normal. That's what this tells us. Now, if we look a little further down toward the middle of this, we can see that it's sloping down. Notice the downward slope. Well, let's go put a measurement on that downslope and have a look at that. When we look at the downslope, we found after 25 seconds, we're down to 0.886 amps. This says we have normal warm-up. This is what we're trying to test. If this current flow is normal and the heater doesn't warm up properly, change the sensor because we've got normal power, normal ground, normal heater resistance. We test both the current flow and the time to activity. And this is the ideal way to do this testing.